6 different polypropylene fabrics were tested in the work direction. The total mass of the fallen carriage with the sharp-edged punctured knife was resulting in an energy of 9 joule. 3 different impact angles, 15, 45, and 75 degrees were examined. Moreover, after the tear, the number of cut ribbon-like weft yarns was counted. Then, we had to measure the total tear length, we had the broken weft yarns, and the total width of the broken weft yarns, simply by calculating how many yarns were in that particular area. After the experiments, we realized that some of the weft yarns were cut, whereas some others they had just only displaced. From this figure, it can be seen that as the mass per unit area of the tested fabric increased, the tear length in all the impact angles used had a diminished trend. Furthermore, the increase of the impact angle by 200%, which means from 15 degrees to 45 degrees, resulted in a reduction of 11 to 33% in tearing length. A further increase in the impact angle from 45 to 75 degrees, which means something like 67%, showed an increased tear length in few fabrics, whereas no significant difference was observed in the others. From the columns of fabric density, it was possible to calculate the width of the ribbon-like weft yarns, assuming the yarns were similar to each other. Thus, for fabric sample number 1, since there were 4 weft yarns per centimeter, the width of each yarn was just only 2.5 millimeters. As the number of broken weft yarns was measured, it was possible to calculate the total torn length of the fabric. During the experiments, as I told you before, it was observed that some yarns were displaced or deformed, forming curves at the end of the tear propagation. Hence, it was necessary to distinguish the calculated tear length due to yarn breakage and the tear length due to yarn displacement. The latter was calculated by subtracting the calculated tear length of the broken yarns from the total measured tear length of the fabrics. In an attempt to correlate the tensile strength of the weft yarns that we measured just before with the total tear length of the fabrics, the linear regression equation was adopted and the following graphs were obtained. Also, you can see the correlation equation that they were derived. From these first 2 graphs, you can see that correlation is not so good for 75 degrees and 47 degrees. But when we come to the angle of 14 degrees, it could be said that it is clear that only in this case, only in this 15 degrees of impact angle, a relatively good correlation appeared between tensile strength and total tear length. Thus, it was necessary, and it is necessary, to continue for further experimental work in a broader range of fabrics, which actually is facing us right now as a team. For the conclusions, I would say that the developed compute device was used for testing the combined puncture and tear propagation of woven fabrics made from polypropylene ribbon-like yarns. Because the method, as well the device itself, is still in the development stage, nothing is perfect. An effort was made to understand mainly the effect of the impact angle on the tear propagation in relation to the mass per unit area of the woven fabrics. For the tested polypropylene fabrics, it could be concluded that the longer tear length occurred when the impact angle was small. In the near future, and which are our plans, various fabric and device parameters like width, shape of the puncture tool, dropping height, will be investigated regarding their effect in the tearing propagation that occurs using this device. The attempt to correlate the tensile strength of the wet fabrics with the tear length of the fabrics was partially successful only with the lowest examined impact angle of 15 degrees. This result expedites the necessity for further experimental work examining the tearing the weft as well as in the bias direction, because tear does not only occur in the warp direction. It is also important to develop a theory taking into account more measuring quantities like the tension under which the fabric is held in its frame and the length of the yarns, either warp or weft, according to the testing direction that is left for displacement. This will help the effort towards the correlation of the yarn elasticity and elongation with the yarn's displacement. Thank you for your attention, to this.
Thank you for your Okay. Let me introduce Professor Primentas from Technological Education Institute of Greece. And I would like to ask him to introduce himself just for a couple of minutes, and then take about 15 minutes presentation and some questions.
2 minutes too much.
2 minutes too much. 1 minute.
That's a simple lecture.
Right.
Mr. Chairman, ladies and gentlemen, good afternoon. I have to apologize, but I have to stick on my text in order to be precise of what I'm going to say. Okay, so be patient for a while, please. Thank you. Although I'm a spinner, and you have asked me why I'm in this session where I can say that all the weavers are. Although I'm a spinner, I'm interested in instrumentation and quality control of whatever comes from the yard, it means fabrics. Therefore, as a part of a European consortium, I would say, we developed a new device for measuring the puncture and tear of woven fabrics. That was about 3-4 years ago. In the meantime, I was working with the senses where this device or this instrument brings to the fore. That's why I used polypropylene ribbon-like yarns, which somehow are the ideal yarns and the ideal fabric in order to apply this geometry that we know. Tearing of fabrics. Among the various defects of textile fabrics, their tendency to tear easily is considered of primary importance. It is described as the sequential breakage of yarns along the line through the fabric. The tearing strength that is usually measured as the force required to propagate a tear may often be used to give a reasonably direct assessment of serviceability. A fabric with low tearing strength is generally an inferior product for a garment, like the lining. In contrast to the tensile strength that involves the force required to break a large number of yarns simultaneously and is relatively insensitive to yarn and fabric structural parameters, the tearing strength is considerably affected by changes in yarn and fabric geometry, the state of relaxation of the fibers, and their frictional characteristics. The ISO standard 4674 specifies 3 methods used for the measurement of tearing strength. These methods, applicably mainly to coated fabrics, are the test using 3-tone specimens, the test using trouser-shaped specimen, and the tear with falling pendulum. In the tongue tear, an initial longitudinal cut is made partway way down to the center of the stripe, and then the two tails, thus formed, are pulled apart, so that a tear proceeds through the uncut portion of the fabric. This test imitates quite closely the type of failure that occurs when one tears a piece of fabric or paper by hand. Furthermore, the ballistic instrument Emmeldorf, the falling pendulum, is biased on the tear propagation of the specimen that was initially cut. Puncture and tear stencing of fabrics. Technical fabrics woven from polypropylene ribbon-like yarns, due to their sufficient strength in various stresses, are commonly used for the transport of heavy goods. These fabrics, as well as apparel fabrics, come accidentally in contact with sharp-edged objects that penetrate and tear the fabric. The American standard of test material D25A2 method that is used for the determination of puncture and tear resistance of flat flexible materials has been designed for thin plastic sheeting, and therefore it is not suitable for testing the various materials used in textiles. As it was mentioned above, the resultant tear of a fabric starts in most cases from the fabric edges. Tear also occurs when the sharp-edged object penetrates, punctures, a fabric, and as it remains inside the fabric, is forced to move towards a random direction. Thus, a new instrument was developed where a suitable test method was applied for the determination of the behavior of woven and non-woven fabrics in the combined puncture and tear propagation. This combined puncture and tear apparatus, named as compute, was developed under the framework of the European Fabric Program Standard and Test Measurement during the years 1998-1999. On this device, materials that are used for the manufacture of casual clothes, special protective garments, and technical textiles can be used. The testing procedure, as well as the principle of the device that is based on the ASTM D25A2 method, is a simulation of the real risks and various conditions that garments and technical textiles are exposed. Let me briefly describe this device. It consists of two main parts, the rigid frame and the specimen holding frame. On the rigid frame, the puncture tool carriage is traveling on two parallel cylindrical rods as it drops from a height of 62.5 centimeters towards the fabric specimen. The carriage of the puncture tool is made of light plastic material, considering as negligible the loss in energy due to friction of the carriage on the rods. Beneath the carriage, the puncture metallic tool is fixed. There are two types of puncture tool, the nail, number 1, and the knife, number 2. The specimen holding frame is placed, this one, is placed behind the rods in the path of the falling carriage, consists of two plates where one, number C, is fixed and the other, number B, can change angular positions of 15, 30, 45, 60, and 75 degrees, determining the impact angle. On the contact surfaces of the plates above and beneath the specimen, there are special grooves, the white arrows, so clear, that assist the specimen to be tensioned evenly in both directions, lengthwise and widthwise. An opening, the letter F, on both plates B and C is for the passage of the dropping edge of the puncture tool. The testing procedure. The step for running a test on the compute apparatus is storage of the fabric sample in normal testing atmospheric conditions for at least 24 hours, no matter the material of the fabric. Preparation of 5 specimens of particular dimensions. Each specimen is placed one at a time on the specimen holding frame. This frame then is placed in its appropriate position in the rigid frame on the apparatus. With the release of the carriage, it drops, and after the instantaneous puncture, it tears the specimen up to a point. The specimen is removed from its holding frame and left for relaxation in normal atmospheric conditions. Then, the measurement of the tear length takes place. In case where either no puncture and tear or a total tear of the lower part of the fabric specimen occurred, these tests are invalid. After the proper adjustment of the weight placed on the carriage, the test is repeated. The measuring technique. Fabric specimen cut in warp and weft directions generally show straight tear, whereas specimens cut in a biased direction mainly present a V-shaped tear. In the case of a straight tear, the measurement of its length can be obtained by a ruler after the specimen removal from its holding frame and its relaxation in normal atmospheric conditions. In the event of V-shaped tear, the total tear length is calculated by adding the 2 straight lines of its sides. In this particular experimental work, we have a variety of plain woven fabrics constituted from polypropylene ribbon-like yarns were used. So it was decided to use these particular fabrics because they could be characterized by an approximation as models, real models, where the ideal plain fabric geometry was applicable. The preliminary tests concerned the determination of the linear density of these ribbon-like yarns. Then we had to determine the tensile strength of these yarns. We have to find out the fabric density. Then the mass per unit area of the fabrics, where the weight of the warp and weft yarns present in an area of 800 square centimeters, was obtained separately. Then, the energy needed for the puncture and tear of the fabrics, as well the tear length, was the last step of the experiment. For this test, 4 specimens of...
I would like to thank all the speakers. Thank you all for attending. Please join me to give them a hand.